Hi everyone, myself Chandrapratap Reddy M from the Department of Electronics and Communication Engineering. Today we are discussing about phase shift oscillator from the subject electronics and circuit analysis. Introduction to phase shift oscillator. A phase shift oscillator is a type of electronic oscillator that generates sine wave. It utilizes a combination of resistors and capacitors to create phase shifts. This oscillator is widely used in audio and signal processing applications. Basic principle of operation. The oscillator operates by providing a feedback loop that reinforces oscillations. A phase shift of 180 degrees is achieved through an amplifier and additional phase shifts from RC networks. The total phase shift around the loop must be 360 degrees to sustain oscillations. Common components of a phase shift oscillator. The primary components includes resistors, capacitors and an operational amplifier. The resistors and capacitors are arranged in a specific configuration to achieve the desired phase shift. The operational amplifier amplifies the signal to maintain the required output level. Phase shift oscillator. Phase shift oscillators are key in electronics and communications, generating continuous sinusoidal outputs via regenerative feedback. They comprise an amplifier and a phase shift network, often including transistor and resistor capacitor sections. Despite their simple design and frequency limitations, these oscillators are popular due to their wide application for signal testing to radio transmission. Modern components and design techniques have improved their frequency stability and their range. RC network configuration. The RC network typically consists of three identical RC stages. Each stage contributes a phase shift of 60 degrees totaling 180 degrees when combined. The total phase shift is complemented by the inverting the nature of amplifiers. Feedback mechanism. Feedback is essential for maintaining sustained oscillations in the oscillator circuit. Positive feedback ensures that the output reinforces the input signal. The balance between gain and phase shift determines the stability of a oscillation. Positive feedback. It is characterized by the condition wherein the portion of the output voltage of an amplifier is fed to the input with no net phase shift, resulting in a reinforce of the output signal. This is called an oscillation. If the feedback circuit returns the signal out of the phase, an inverting amplifier produces positive feedback. Frequency of oscillation. The frequency of phase shift oscillator is determined by the values of resistors and capacitors. The formula for calculating the frequency is F is equals to 1 by 2 pi root R 2 pi RC root 6. Adjusting R or C values can tune the frequency for specific applications. Prove that the frequency of oscillation of the phase shift oscillator circuit below is F is equals to 1 by 2 pi RC root 6 and the feedback factor gain must be at least 1 by 29. Design an operational amplifier phase shift oscillator to produce a 10 kHz sinusoidal wave. Use power supplies of plus or minus 12 volts. Given that the frequency of oscillation for that circuit is Fr equals to 1 by 2 pi RC root 6, and the required gain of the amplifier is modulus of minus RF by R, that equals to modulus A is greater than 29. Advantages of phase shift oscillator. One advantage is that it generates a pure sine wave output. It has a simple circuit design, making it easy to construct and implement. The oscillator is stable over a wide range of frequencies, which is beneficial for various applications. The amount of actual phase shift in the circuit depends upon the values of the resistors and the capacitors and the chosen frequency of oscillations, with the phase angle pi being given as x equals to 1 by 2 pi fc, z equals to square root of r square plus xc square, pi is equals to tan inverse of xc by r. Disadvantages of phase shift oscillator. One disadvantage is that the output amplitude may decrease over time without proper gain control. The circuit can be sensitive to component tolerances, affecting the frequency stability. It may require careful design to ensure low distortion in the output signal. Phase shift oscillator in practical design. The last R has been incorporated into the summing resistors and the input of the inverting operational amplifier. Fr equals to 1 by 2 pi root 6 RC, that equals to K is equals to RF by RS into 29. Applications of phase shift oscillator. Phase shift oscillator are commonly used in audio signal generation. They are utilized in function generators for testing and measuring purposes. These oscillators can also be found in music synthesizers to create various sound effects. In comparison with other oscillators, unlike a Colpitt's oscillator, a phase shift oscillator does not rely on inductors. Compared to Wien bridge oscillator is simpler but may face stability issues. Each type of oscillator has unique characteristics suitable for different applications. Colpitt oscillator circuit. Here F0 equals to 16.7 MHz and F0 equals to 15.9 MHz. It is measured. Circuit diagram of phase shift oscillator. The circuit diagram illustrates the arrangement of resistors, capacitors and the operational amplifier. It showcases how the RC network and feedback loop are configured. Understanding the circuit layout is crucial for effective troubleshooting and design. This is the RC phase shift oscillator circuit. Designing a phase shift oscillator. Designing involves selecting appropriate resistor and capacitor values for the desired frequency. It is important to ensure that the gain of the amplifier meets the oscillation criteria. Simulation tools can be used to validate the design before physical implementation. The amount of actual phase shift in the circuit depends on the values of the resistors and capacitors and the chosen frequency of oscillations, with the phase angle pi being given as x equals to 1 by 2 pi fc, r equals to or z equals to square root of r square plus xc square, that equals pi is equals to tan inverse of xc by r. Stability considerations. Stability is a critical factor that affects the performance of a phase shift oscillator. Component tolerances can influence the oscillation frequency and amplitude. Techniques such as using precision components can enhance stability in the design. AC power flow control of a transmission line. Here, figure A shows a simplified case of power flow on a transmission line. Locations 1 and 2 could be any transmission substations connected by a transmission line E1, E2 are the bus voltages with an angle delta between two. The driving voltage drop in the line is the phasor difference EL between the two line voltage phasor C1 and E2. The line current magnitude is given by I is equals to EL by X and lags EL by 90 degrees. The current flow phasor is perpendicular to driving voltage 90-degree phase lag. If the angle between the bus voltage is small, the current flow largely represents the active power. Increasing or decreasing the inductive impedance of a line will greatly affect the active power flow. Thus, the impedance control, which in reality provides current control, can be most cost-effective means of controlling the power flow. Testing and troubleshooting. Testing can be performed using an oscilloscope to observe the output waveform. Common issues include frequency drift or amplitude fluctuations that need to be addressed. Troubleshooting may involve checking component values and connections in the circuit. Basic waveform analysis with an oscilloscope. Enhancements to phase shift oscillator. Adding feedback control can improve the stability and performance of the oscillator. Incorporating temperature compensation can help maintain frequency stability. Utilizing low noise components can enhance the quality of the output signal. Advanced phase shift designs. Advanced designs may include multiple phases or variable frequency capabilities. These designs can cater to more complex applications in modern electronics. Digital control can also be integrated to allow for programmable frequency adjustments. Digital versus analog phase shift oscillators. Digital phase shift oscillators use digital circuits to create oscillations. Analog circuits provides continuous waveforms while digital oscillators generates discrete signals. Each type has its own set of advantages and disadvantages depending on the application. Future trends in oscillator technology. Ongoing advancements in semiconductor technology are shaping oscillator designs. Integration with microcontrollers and FPGAs is becoming more common. Future oscillators may focus on improving energy efficiency and reducing size. Here are the top 8 future technology trends that we should know. The first one is artificial intelligence. Second one, Internet of Things. Third one, genomics. Fourth one, genobots. Fifth one, blockchain technology. Sixth one, extended reality. Seventh one, quantum computers. Eighth one, energy storing bricks. Summary of key points. Phase shift oscillators are essential tools in signal generation and processing. They offer a simple yet effective approach to generating sine wave signals. Understanding their design and operation is crucial for effective applications in electronics. Here f0 equals to 1 by 2 pi RC into root 6, that equals to RF by RR is equals to 29. The gain must be at least 29 to maintain the oscillations. Conclusion of phase shift oscillator. The phase shift oscillator is a reliable method for generating sine wave signals in electronic circuit. It utilizes a combination of resistors and capacitors to create the necessary phase shift for oscillation. Phase shift oscillators are key in electronics and communications, generating continuous sinusoidal outputs via regenerative feedback. They comprise an amplifier and a phase shift network, often including transistor and resistor capacitor sections. Despite their simple design and frequency limitations, these oscillators are popular due to wide application from signal testing to radio transmission. Modern components and design techniques have improved their frequency stability and range. This oscillator type is widely used in audio applications, waveform generation, and signal processing due to its simplicity and effectiveness. Thank you.